Okay, hello, welcome to SQL Saturday, and thank you for coming on Saturday in your free time. This lecture is going to be about what? What are we going to talk about today? Transactional. Yay! So you are paying attention. Great, you are awake, so we can start, I think. Before we go to the subject, I want to thank to our sponsors and the organizers, because without them this event wouldn't be possible. So please take several minutes out of your time and go to the booths and speak with the sponsors. So, about me, my name is Miroslav Dimitrov. I'm coming from Bulgaria. I am a cloud engineer at KPMG. By the way, if you have read the articles here on this blog, you can go away. I will not tell you anything new. I was just joking. What is important here on this slide for you is my email address. So in case there are some questions that you still want to ask after the session and due to any reason you didn't have time or you didn't have chance to do it, you can always drop me an email and I will try to respond as soon as possible. The slides would be uploaded on the SQL Saturday site. On the schedule tab, you can have a download link below each of the presentations. I think I will upload them later today. So you do not need to write this information. The agenda for today, first I'm going to try to explain a bit more about the structure of the transaction log, and we will do a short introduction. We will start a bit shallow, but then we will go deeper, so I would like to follow me from the beginning, because it's very important to make this transition from the structure to the reasons about performance problems, because we are going to build upon the structure of the transaction log. Second, our focus would be the reasons about performance problems, or the reasons that are contributing the most to these issues, in my opinion, in my experience. And last, we will see some configuration suggestions and some things you can do in order to mitigate the risks of having issues with your transaction logs. You had already your coffees? You ready to start? Okay. I already had 3 coffees, I believe, so I'm pretty much awake. The story behind this session, I just want to share with you for 1 minute, is that I needed to create a mirroring session. I believe it was 1 or 2 years ago. A very simple mirroring session, synchronous mirroring between two servers. And the session was running, but I was receiving a lot of timeouts. And I was wondering what's going on. Is it the network? Is it my configuration? How come the mirroring is not working? Really simple mirroring. I was following the very simple guides. Okay, but it wasn't working, and it happened to be that the root cause of my issues was my transaction log. So I was having my transaction log misconfigured in a very bad way, and it was giving me issues. It was timeouting all the time because the core transaction log operations wasn't running at the speed I needed to run. So I will tell you actually in a few slides the root cause, but for now, the transaction log was the reason for me. So that's why I decided to dig into this topic and eventually create this session. So I shared with you my experience. Now I want you to be part of this session. I want you to be engaged. Can you please take out your phones, laptops, tablets, whatever it is? I hope you have internet. Go to this slide, slido.com, and enter this code. You can do it now. Please take out your phones, go to slido.com, enter 5038. Okay, I have created a small poll for you, and I want to see how many people in the room actually have experienced issues with the transaction log. Just 1 second to duplicate my screen. Yeah, you will see it in a minute. 5038, sorry, it's there. Okay, not sure. It's just a simple answer for the time being. Yes, no, or actually you weren't sure if your issues were coming because of the transaction log misconfiguration or performance or anything. Okay. So not sure, a lot of people, not sure. Okay, yes, no. I was hesitating whether should I put an answer that I am a lucky guy and I do not have issues with the transaction log, but I decided, this is not too realistic. So I stick with this answers. Okay, yes, no, not sure. Okay, 23 people voted. Let's wait 1 more minute before we go back to the slides. Yes, okay, 50%. That's interesting. Okay, 47. Okay. Okay. By the way, the poll would be left active for the next few slides, so you still have the chance to vote. I will then present back the results. So 47% yes, no, 26 not sure. Okay, let's go back to the presentation. Okay, that's great. Okay, so now first part, walk structure and introduction. I want to help me here with the structure of the transaction walk. I have several questions for you, so pay attention. Okay, the transaction walk file is actually something very important for the database. It keeps the database integrity, and actually it's something that it should be, should be intact for a database to be in an operational state. Because if there is something wrong with your transaction walk, there is something wrong for sure with your database. Now, in general, the transaction walk maps over one or more physical files. Usually, it's only one file. And for simplicity, we will look now at the example with only one file. This is one physical file. I mean, this LDF file, usually LDF file, on your file system. But internally, how SQL Server is operating is a bit different. SQL Server internally divides this physical file into many small files that are called virtual walk files. Usually there are a lot. Again, for simplicity, we only have two on the slides. Virtual walk 1, virtual walk 2. In these virtual walk files, we have these another structures that are called walk blocks. They are important because they are actually the size that SQL Server is using to flush the walk records from the memory to the disk. We will see this thing in a minute. For now, just remember that the walk blocks are between 500 bytes and 60K. They are just containers for the walk records. Inside this walk blocks, we have walk records. Each walk record is representing a single change in our database. You can imagine it as insert, delete, update, operations you are doing against your database. As the time goes, SQL Server is fulfilling the walk blocks and the other virtual walk files with walk records. And when SQL Server hits the end of the walk, the end of the physical file, SQL Server doesn't try to outgrow the file immediately, but this walk file is actually using this thing called wraparound nature. So SQL Server is trying to start from the beginning. So it's trying to reuse the first VOFs. In order for SQL Server to do this, something has to happen in advance. We need to clear these virtual walk files in an operation called walk clearing, or probably it's more famous as walk truncation. Okay, can you tell me when walk truncation happens in SQL Server?
Commit transaction.
Commit, okay, not exactly.
Backup.
Recovery model, okay, and what's the difference between the recovery models? Can you explain it?
If you have a simple recovery, just when you commit on a snapshot, you can truncate the data. And if you are doing a full, or you basically need for transactional backup or full backup to take place.
With full backup, are you truncating the walk?
No.
Okay. Okay, yeah, it's close. So actually, walk backup is the only thing that is truncating the walk, or is attempting to truncate the walk in full recovery model or bulk walked recovery model. Nothing else is trying to do it. In simple recovery model, it's true what you said, but it's not entirely true. SQL Server is trying to do this on a checkpoint operation. But checkpoint doesn't always come with the commit of your transaction. We will see this in a minute. It's usually every 70% of data and other conditions you have to meet. But it's during checkpoint operations. So SQL Server is trying to do this walk clearing, and if all the records in this virtual walk file are not required anymore, which means that they are not part of long running transaction, they do not need to be sent because you have a high availability feature running, or you do not need them for change data capture or anything else, SQL Server is able to clear this virtual log file. When it is cleared, SQL Server can reuse it. But if all of your VOFs files are currently in use and SQL Server hasn't been able to clear them out, the transaction log has to grow. Okay. Any questions here? About the structure for the time being? Okay. Next slide. We continue with the transaction log. The transaction log is being used when you recover single transactions, when you actually starting up your databases. So it means that you can recover a bunch of transactions, not only one. It's being used when you're using high availability features and a lot of situations. It's basically very, very critical. And SQL Server is using one mechanism actually to make sure that when you commit a transaction, for example, you commit a transaction and right after the commit, in 1 millisecond, SQL Server shuts down. But as you already committed your transaction, SQL Server is using a special mechanism in order to ensure that next time you start up your SQL Server and your database is being recovered, the changes that you have made via this transaction would still be persisted in the database. Do you know the name of this mechanism? Sorry, louder? Redo.
Rebuild, he says.
These are the operations that are happening when you are starting up your databases. These are the recovery phases you are naming. But I'm just looking for the mechanism that SQL Server is using to make sure that, okay, I will give you a hint. No changes are written to the disk. Changes, you can imagine it as data pages. No data pages are written to disk before the associated log records are written to disk. What is the name of this mechanism? Write-ahead logging. Okay, this is what I was looking for. So, if SQL Server doesn't comply with write-ahead logging, and you do this commit thing, and you flush your data page from the memory to the disk before the log records, and something happened, a disaster, SQL Server shuts down, you're creating actually a change that cannot be rolled back. So this is very, very important. And how SQL Server is changing data, I want to imagine that this is the buffer pool, the memory that SQL Server is using. I'm not that good designer, so don't blame me about this picture. But you see, this is the memory SQL Server is using. The white squares are actually the clean pages, which means that the version of the page on the disk and in the memory are the same. The gray ones are actually the dirty pages, you can imagine. And this small L thing there is the log cache. So something very important here, there is a common misconception that as you are doing changes in your database, as you are inserting, deleting records, everything that you are doing is directly being written to the disk. This is not true. As you are doing changes, log records are being generated and stored in this memory portion of the SQL Server called log cache. So initially, you have your log records in the memory, the same as the data pages. And SQL Server is flushing these log records, which in terms means that it's just taking them from the memory and saving them to the disk in 3 situations. First situation, you already mentioned it, when you issue a commit or rollback for a specific transaction. When you issue a commit for a specific transaction or rollback, SQL Server is flushing all the records from the memory to the disk. There is no selective log flushing. So actually, you're not flushing the log records that are only part of this transaction, but you're flushing the all of the log records that are currently in the cache. No selective log flushing. This is very, very important. Okay, next situation is when you hit a full log block. That's why log blocks are important. So if you have a long running transaction that doesn't issue a commit within this 60K of the log block, when you hit this 60K, SQL Server is issuing a log flush in order to be sure that it will reduce the time for recovery. And third situation, do you know what is the third situation when SQL Server is doing these log flushes? Shut down, yeah, but okay, it's not directly, but good answer. I will explain it in a bit. Good. Okay, anyone else? Yeah, okay, when SQL Server is shutting down the database, internally SQL Server is issuing a checkpoint. Yeah, so checkpoint doesn't guarantee actually that you will flush the log records from the memory to the disk, but what checkpoint is doing, and as well lazy writer actually, is taking the dirty pages from the memory to the disk. And when you are taking the dirty pages from the memory to the disk, SQL Server has to write all the walk records before the data page in order to comply with the write-ahead logging. So there is something small but important. In each page, in the header of the page, you have the walk record that has most recently changed the page. So before SQL Server saves this particular page for example, on the disk, SQL Server has to flush all the walk records up to including this one that has changed the page in order to comply with write-ahead logging. Otherwise, you end up in a situation where you are creating a change that potentially might not be able to roll back if SQL Server shuts down before you send the walk records from the memory to the disk. Okay, questions here again? It's probably it's a bit deep, but it's very important for our next section. So I really want to understand this part. If anything is unclear, please ask, shoot. I'll try to explain it. Okay, then go to next section. This is our main focus. I have identified 5 reasons that, in my opinion, are contributing a lot to performance problems with the transaction log. First, unused non-clustered indexes, walkout to growth setting, high availability features, fragmented indexes, and many tiny transactions. So, unused non-clustered indexes. Okay, when you have a lot of non-clustered indexes in your database, each time you are inserting or deleting records, SQL Server has to update these indexes. Okay, not saying something new, not reinventing the wheel, but what is the idea here? The idea is that you are generating walk records for each of these operations. So if you have one single insert towards your database, you have 5 non-clustered indexes, you can imagine that these are at least 5 more additional inserts that you need to do. Okay, this is good, this is acceptable, this is by design, but what's going to happen if you are not using your non-clustered indexes? So they are staying there in your database, wasting space in your maintenance strategy, wasting space in your backups, and on top of this, you are not using them to satisfy your queries. So if you are not using them, if you are not, if they are not contributing to your performance, it's a good idea to disable them or directly drop them. So there is a DMV that you can use in order to see which indexes you are not using and you are not benefiting of. Do you know the name of the DMV that you can use in order to see which indexes are being used? Okay, any guess? Okay, I believe that it's very simple, yeah? Okay, this is DMDB index usage stats. So this is a DMV that is very good, but there are some, certain caveats with it. I will show you this during the demo. Okay, let me show you this thing. Okay. Can you read the code in the back? Is it okay? I will zoom when it is required, but okay, so I will use AdventureWorks Data Warehouse 2008 R2 database. It's a free database, you can download it. I will just want to be sure that I will take a clean copy of this database. That's why I will copy it from my file system. Okay, XPC in the shell. Okay. Okay. Now I need to attach this database. Okay. Should be there. And now I'm doing something that I will explain at a later stage. I'm deliberately turning off the auto creation of column statistics because I want to show you something. Okay, I'm including the actual execution plan, and now I have a very simple query here. You can see I want to select something from where. Okay, I want to execute this and show you. Okay. So, estimated number of rows and actual number of rows. Now you can see SQL Server has estimated that this query would return 3000 rows, but actually I returned only 500 rows. Okay, this is because I'm missing statistics. Good. This is not the idea actually of this demo. So pay attention. I'm creating one index on this column, tax amount. See the index, non-clustered index. Okay, and I will run the query again. Any bets what's going to happen with the actual and estimated number of rows? Would I still have this issue? Should okay, but if you are paying attention, I'm using the same one, clustered index scan, so I'm not using the new index. What is your guess then? Okay, let me show you. Okay. 562, 562. The question here is, did I use the index? The newly created index, I mean, not the clustered one. Clustered one is obvious that I have used it.
No.
What did I use then in order to fix the cardinality? Statistics. Okay, great. So, if I go to this DMV that I mentioned to you and select and actually filtered out by the name of my index, I would not be able to see anything because I didn't use the index. I used the statistics that the index provided. And now, if I drop the index, okay, I dropped the non-clustered index, I'm having the same issue here. Okay, so this is what I wanted to show you, that this DMV, first of all, it's not persistent, which means that, of course, it's clear that if you restart SQL Server, the information there would be gone. But if you are restoring your database, if you are rebuilding this particular index that you are interested in, if you are detaching or attaching your database, this information for your database would be cleared out. And also, this DMV is not showing you when you use the index statistics. So in order to trust the information that is coming from this DMV, you have to create some kind of a solution, if you want to call it a maintenance solution, cycle solution, whatever, that is pulling the information from this DMV, let's say every hour or so. It depends on your environment. And actually, it's saving this somewhere else. And you can examine this information at a later stage. Let's say that your applications are running in a maintenance cycle within 1 month. Maintenance cycles, I mean that where you're using index rebuilds and stuff like this. The better solution is actually to take this information periodically, save it, and examine it once a month, once in every 2 weeks, or something like this. Do not just go, select star from this DMV, see which indexes are there, and drop the other ones. No, this is not the correct way to do it. This is the important thing I want to take from this DMV. Okay, go back to the slides. Walkout growth setting. Another important thing. Are you actually changing the default walkout to growth setting of your databases? Yes? Someone said yes. Okay, why you're doing this? Is it because you don't like the default number, just to align it with your strategy or something, or there is a reason behind it?
Most of the times it's not good.
This is not good? Okay, why is it not good?
Because if I know the size that it should be normally, I set this.
Okay. Okay, walkout to growth setting is something very important that you should always set up when you are creating a new database. Do not live with the default size. And what is the problem here? The problem is SQL Server, if you grant SQL Server permissions, SQL Server can use this rights code perform volume maintenance tasks, which means that SQL Server does not need to zero initialize the portion of the disk when you are creating your data files or you are expanding them. So literally, you can create 1 terabyte of a data file instantaneously, almost instantaneously. But for the transaction log, this is not the case. Even if you have this policy, SQL Server cannot take advantage of it because of the recovery process. Microsoft has decided that there is a risk if the previous data that has been occupying this portion of the disk looks something similar like log records. SQL Server might try to recover a bit further your database when you are starting it up, and you can receive something strange, something inconsistent for sure. So for the transaction walk, you always need to zero initialize. And imagine that if you are in the middle of your monthly reports or your very important workload that is happening each month, in the end of the month, and you are right at the middle, and SQL Server has to grow your transaction walk, and your step is 10%. 10% of, I've seen one of the largest transaction walks I've seen was 2 terabytes. So 10% of 2 terabytes, 200 gigs. And SQL Server, what is doing? SQL Server is waiting for this 200 gigabytes to be zero initialized, basically to write zeros. And it's waiting, and your workload is waiting as well. Because this is pausing the log flushes. When SQL Server is zero initializing, you cannot do the log flushes. Without the log flushes, SQL Server cannot send the commit record to the disk. And without this possibility to set the commit record to the disk, your transaction is not actually committed. SQL Server cannot deem your transaction as committed. So you are still holding the logs that your transaction is using, and you are still occupying the resources that your transaction is occupying. So you are in this deadly circle, if I may put it this way. So walk out to growth setting is very, very important. You have to be careful with it, and you have to close pay attention to the transaction log. High availability features. I will not go too much details with high availability features, but in any case, if you have a high availability solution of any kind and your secondary replicas, mirror, whatever, is not catching up with your primary, SQL Server has to keep the primary transaction walk records around, and if it is not able to send them, you are not able to do this walk truncation, walk clearing, what we already covered, and it's highly likely that your transaction walk would need to grow more often than it needs to grow in a normal situation. This is with regards to the high availability feature. Next two things I have identified are the fragmented indexes. Okay, what is the issue with the fragmented indexes? Have you seen any problems with them? If you have a highly fragmented index? Okay, anyone? Okay, what is the issue if I have a high fragmentation on my index? What is the impact on my transactions, on my workload? Is it okay? Is it bad? You have to read what? Sorry? You have to read more. Okay. So yeah, fragmented indexes are generally assumed as a problem when you're reading a lot of data. While this is true, with regards to the transaction log, there is one more additional problem. Do you know how fragmented indexes are becoming fragmented? What is the process of receiving a fragmented indexes? Can you explain it?
Yeah, because of the deletes, hard deletes.
Because of the deletes?
Because of the deletes, because of the updates, basically everything that changes the index.
Okay. But what's happening in terms of the structure of the index? Why you receive this this fragmentation? Page splits, yeah. This is what I was looking for. So the reason, or not the reason, but how SQL Server is actually generating these fragmented indexes is page splits. So you have one page that you need to put your records inside because of the order. Let's imagine we have a clustered index. And when there is no space, SQL Server has to allocate a new page. You have to transfer some of the records from your old page to the new one. You have to hook up the new one to the current index structure, and then you will insert the new record at the page you need to insert it. All these operations, you can imagine, are generating log records. So when it comes to a transaction log, fragmented indexes are very problematic. Do you know the DMF that we can use to see which indexes are fragmented? It's very similar to this usage stats, but with a slight difference. Physical stats. Okay, physical stats. You can use this function to see which indexes are fragmented. Okay, let me show you one demo now. See the effect of page splits when it comes to the transaction log. Can you read this one as well? Okay. Okay, so I will use a database called page split test. Okay, I'm dropping. There is a database. And see what I'm going to do. I'm going to create a table, 2 columns, create a clustered index on them, and deliberately miss number 5. Okay. Very simple demo. Nope. I needed to create a table probably. Yeah, okay, now it's okay. And now I will create a transaction that is inserting value 8. Value 8 is after my value 7, so I'm not expecting any issues. So this is, let's say, the normal situation where you won't have a page split. And I'm using transaction log bytes used from sysdmtran database transactions to show you how many bytes I will generate. See the number, 1000 something. It's not that important. Okay, now I will do the same, but with 5. So I will commit the previous transaction and do the same thing with 5 and see how many data I would generate in terms of transaction log. You see the ratio? Around 7 times 6.5 more bytes I'm generating because of the page split, because I generated way more transaction log records than with the previous situation. If I do the same exercise but with smaller data, I will just go a bit faster because you already know the scenario, but see, just I'm using char 100 here. Okay. And I'm missing 30. Oop. Sorry. Just the wrong button. Okay. Okay. My mouse is giving me troubles today. Okay. 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 So I will insert 72. That would not generate page split. And see. Okay. This is 300 bytes. The number is not that important. See the ratio. I'm committing the previous transaction, and now 6,000. So the ratio is around 17. So as the data gets more, the ratio becoming worse actually. So page splits are very painful for the transaction log. Now you have to be careful with indexes that are becoming fragmented so often. So what is the solution that you can do? You can use this setting called fill factor in order to proactively reserve space in your indexes in order to mitigate the risks of having too many page splits. Okay, let's go back to the presentation. Okay. And last thing that I identified, many tiny transactions. What do you think means a tiny transaction? How do you see it? When someone like me says to you, okay, you are using a lot of tiny transactions. You don't see this very well, but okay, you see the word tiny. Okay, what is your perception about tiny transaction? When you heard tiny transaction, what do you think? Anyone? Brave souls here? Single row insert. Okay, yeah, this is what I was looking for. So you're actually doing single row inserts, or if it is not single row, you're operating on small chunks of data. As we already talked, you're doing log flushes each time SQL Server receives a commit. You're doing log flushes of all your log records from the memory to the disk. So if you're using a lot of tiny transactions, single row inserts, and you need to do single row inserts, let's say 100,000 times, you can imagine that these are 100,000 log flushes. So what could happen here is you can basically overwhelm your disk I/O subsystem where your transaction log is sitting. Basically you have two options. If your transaction log is sitting on a low-performing I/O subsystem, you can overwhelm it with these workforces and you can receive a lot of latencies. If you move to a high-performing I/O subsystem, there is another problem. Because if your transaction log disk is so fast, let's imagine you are using SSDs, now they are not that expensive, they are affordable, but there is another issue. If your transaction log disk is able to keep up with the log forces, there is a certain limit of SQL Server you cannot go around, you cannot circumvent. This is that you have only 32 concurrent log flushes for a particular database. So if you are hitting this limit of 32 concurrent log flushes, SQL Server is waiting and idling. Even if your disk is that fast, that can handle the log flushes you are sending very often, SQL Server would still be sitting and waiting for these 32 outstanding IOs. This limit is per database, so if you are having this issue, it's a bit problematic because solution is to split the workload over more databases, not using only one database. But what you can do, if you are in the first situation with a low-performing I/O subsystem, you can always move to the high-performing I/O subsystem. But if you are in the second case, you have to think of a solution how to actually decrease the number of log flushes that SQL Server is handling. And also, one more solution, probably very counterintuitive, but in both situations, even high or low I/O subsystem, you can do something that is probably strange, but you can make your transactions larger. Rather than using single inserts, let's group them in, let's say, 10 rows inserts, 100 rows inserts, depending on your data. There are here, again, one DMV and one DMF you can use. First one, virtual file stats. You can measure the latency against your transaction log disk. You want to see something under 5, let's say 10 milliseconds, something like this. And second one, pending I/O requests. With a bit of calculations, you can see the outstanding IOs for your database. Okay, and as we are talking about many tiny transactions, sometimes I know that this sounds good, but I am a DBA, I don't know your profiles, but in most situations, I am not able to push the developers to change their codes. Even that they do not trust me, or it is because they cannot simply change the code in the application that easy. So if it is not that easy to do it, and we are not able to make our transactions larger, there is something new and that has been released with SQL Server 2014 called delayed durability that can help in this situation. Have you used this feature? Do you know it? Delayed durability? Okay. Probably you can judge by the name what this means, but if you turn it on, SQL Server is simply taking out the D property of the transaction, ACID is taking out the durability property of your transaction, and you are basically rolling dice because you have a potential of losing data. So something very important before I go deeper in this feature is that I want to stress on this. If you are planning on using it, you have to tolerate data loss. Keep this in mind. Another question is how much would this data loss be, but you have to tolerate data loss. So if you are running a bank system, something with money, I don't know, something very important, this is probably not a good option. But if you are holding, let's say, temporary session information, stuff like this, probably it's a good thing. It's a good thing to use. Okay, I will give you more information about this delayed durability while I'm doing the demo, because I will need around 50 seconds for my code to finish. Okay. Yeah. Want to connect this. Okay, delayed durability. What I will do, I will create two databases. First one is DD1 that have delayed durability disabled, and second one is DD2 that have delayed durability forced. So delayed durability can be set on database level, on the individual transaction level, and if you are using natively compiled stored procedure. But the database level has precedence over the other two levels. So if it is disabled on your database level, even if you try to do it with individual transactions or natively compiled stored procedure, it won't work. So I will use these two databases. They are in full recovery model. Basically no other changes. Both databases will be using my local SSD drive. They will use, you see, full recovery model, just delayed durability option is different. Okay, and what I will do now, I will show once again their property. So DD1 is the standard database, DD2 is the one that is going to use delayed durability. Walk disk is SSD for both of them. Okay, I'm generating 2 tables. Nothing special here. Just 2 tables in both databases. You see the structure. I have int identity column and I have date time and unique identifier with default values. Okay. Because I'm lazy, I want to start the code and do the things for me. I will use a temporary table to measure the performance of both databases. So this would not generate anything. I will just create the temp table. You see, 0 rows affected. So the temp table is empty. And now what I'm going to do, I'm going to do 100,000 single inserts. Okay, this is for DD1. Then I will do the same for DD2. And then we will check the statistics. So while this thing is running, I mentioned SQL Server just takes out the D out of the transaction properties. So SQL Server optimistically assumes that the walk flushes would happen. So when you send your commit walk record, SQL Server doesn't wait this walk record to go to the disk and receive this acknowledgement. Okay, I was saved on the disks. It's good for you to go. SQL Server returns you that your transaction has been committed, releases your walks, resources that are being held, but the walk records are being grouped in this walk cache, in this part of the SQL Server memory, and SQL Server is trying to save them when the walk block is as close as possible to 60K, when you are as close as possible to the limit of the walk block, or there are a lot of situations that can change this, but it's trying to do it as close as possible. Also, there are transactions that are always fully durable, which means, for example, that if you're using change data capture transactions, some special cross-database transactions, they are always fully durable, which means that if they are between your delayed durable transactions, when you use a fully durable transaction, SQL Server will flush all the walk records from the memory to the disk, including for both types of transactions, because there is no selective walk flushing. And also there is a stored procedure, system stored procedure you can use to force SQL Server to save all the walk records from the memory to the disk, which is called sys_sp_flush_walk. Something very important as well here, in addition to the fact that you need to tolerate to data loss, you have to know that with delayed durability, there is no graceful shutdown of the SQL Server. So even if you are doing it gracefully and not as part of some kind of disaster or anything, you shouldn't plan on having SQL Server saved these walk records from the memory to the disk for you. In most situations it would do it, but you shouldn't plan on it. So try to use this stored procedure I mentioned to you in order to flush these walk records. Okay, query is being executed. And also, one more thing to add, this feature is available in all editions, so you can use it even in Express edition. Okay, let's see now the difference. Okay, so first database, normal one, I have done around 1100 writes against my transaction log. And you see the number of bytes per write is around 4,000, 4K. See, stall milliseconds, how much time I was waiting for my walk flushes, and the duration of whole operation, 43 seconds. With delayed durability enabled, it's 26 seconds. I was waiting only 300 milliseconds for the walk flushes, and see, yeah. okay, it's not that close to 60K, but it's still 20K. So I've been flushing my blocks with 20K size. Not 4, but 20. Okay, if you are wondering where the difference is coming, because for example duration is 43, and if you take out of 43 roughly 10 seconds, it's 33, and for other is 26. It's because just the throughput of the SQL Server is bigger. I mean, the number of batches per second I can do with delayed durability is bigger. That's why there is a slight difference in the time. Okay. Okay, good. Any questions about delayed durability or anything else? Okay. Because we are at the end of this section, we covered the top reasons for transaction log performance problems, unused non-clustered indexes, log auto-growth setting, high availability features, fragmented indexes, and many tiny transactions. So now I want you to participate again. Sorry, I will wake you up a bit. Okay, go to this Swallow. Just 1 sec. Just 1 sec. I need to disable this voting. Okay, so this is the final result. You don't see it, sorry. Okay. This is the final result of the first question. Now I want to deactivate this and activate the second one. What were the reasons for your transaction log problems? A lot of people said that you don't see the last one. Okay, they will start moving around when you start voting. So I think around 50% said that they were experiencing issues with the transaction log. So now, okay, I want to see, as we covered the reasons, in my opinion. Okay. By the way, this is multiple choice, so you can pick more than one answer. The first poll was with only one answer allowed. Okay. Walk out to growth setting. Okay, good. Okay, while we are voting, I will present again the results at the end. I will go back to the presentation, so I'm running a bit out of time. My last section is configuration. I promise to be a bit fast. So there are several things you can do in order to streamline the work of your transaction logs. First, initial size. Do you know what is the initial size of your transaction log if you just send a statement, create database test2? What transaction log SQL Server would create for you? 1 megabyte or 100? 1 megabyte. Okay. Okay, it's not entirely true. The correct answer is actually, it's not 1 megabyte, to be honest. It's half a megabyte, which are 2 VOFs, 250K, is the larger of half a megabyte and 25% of your data files. So it depends on how large your data file would be. And your data file would be taken from the model database if you just hit create database something. So if your model database is set on something like 100 megabyte, you will receive a transaction log of 25 megabyte. Actually, they changed the formula in 2016, but I think this is enough for now. But just bear in mind that in 2016, it's a little bit different, this calculation. So important thing, initial size is not usually the best thing for you. Or do not try to live with the default one. Try to make an educated guess about what is the perfect size for your transaction log, for your environment. I know I have received a lot of questions, what is the perfect size? There is no that magic number, but you can start with something like 10-15% of your data files and trying to guess based on how is the workload running, if you have high availability features. Very important is what log backup solution is using and how frequently are your log backups. The best thing to do is if you have a development environment where you can set up your database initially and try to see how it's going and if the size that you picked for your transaction log is the perfect one. Okay, number of VOFs. number of VOFs are very, very important. If you have a lot of VOFs, actually this was my issue with the mirroring. I was having something like thousands of VOFs. If you have a lot of VOFs in your transaction log, this is slowing down the transaction log work and slowing down the recovery processes, slowing down your high availability features. But what is the formula about the VOFs? So the formula is the following. If your SQL Server is growing your transaction log with this number that I'm going to quote right now, or if you're creating a new log, there is no difference. SQL Server is still using this formula. So if you are expanding or creating a new log between 1 megabyte and 64 megabytes, SQL Server is creating 4 VOFs. If it is between 64 megabytes and 1 gig, it's 8 VOFs, and if it is above 1 gig, it's 16 VOF. And each time, the VOFs are roughly with the same size, which means that if you are expanding your transaction log with, let's say, 8 gig, in this formula you will receive 16 VOF, 8 gig, 16 VOF, each VOF would be roughly 500 megabytes. In 2014, they changed the formula. So now, SQL Server first is checking if the size that you are going to expand your transaction log with is less than 1/8 of the current size, which is around 12%, 12.5%. If the answer is yes, SQL Server is only creating 1 VOF. If the answer is no, it's still using the formula I quoted. For larger databases, probably the formula in 2014 is the better approach. So if you're having issues with the number of VOFs, what you can do is you can shrink back your transaction log to a relatively small size and try to expand it with proper steps, having in mind this formula. Okay, TMDB log. TMDB log is something very strange, probably a bit buggy behavior, but when you restart SQL Server, or SQL Server has been restarted due to a disaster, actually what is going to happen with your TMDB log is that SQL Server is reverting it back to the size it has been most recently set to, which means that if you have manually set it to, let's say, 1 gig, but it has outgrown several times to 10 gigabytes in order to accommodate your normal workload, SQL Server will revert it back to 1 gigabyte. We will not keep the last size. This is important because if a disaster happened and your SQL servers have been restarted in your whole environment, this could be a potential for a lot of issues, and you have to keep this in mind and implement some logic in order to check it. Okay, shrinking. Shrinking is not that bad as with the data files. Shrinking of the logs, I know sometimes it's necessary, but if you are doing these shrink operations very often, you shouldn't keep doing it without a particular reason. So if of course there is no issue with your free space on the transaction log drive, just accept the new size as the original size and live with it. Larger transaction log is not that problematic. I mean larger in terms of physical size of the file. If there are a lot of VOFs, this is another story, but larger is not a problem. Of course, if there is a problem with the space on this disk, okay, you have to try to figure it out why this is happening. I mean, you have to see why you are doing that many log flushes, why you are not actually able to clear your logs at the pace you need, why, for example, your log backups are running every 2 hours and in your environment it seems that this is not enough. So try to find the reason and do not just accept it. Okay, SQL Server transaction log is growing, I would shrink it, it will grow again in 1 month, I would shrink it, stuff like this. Because if you are doing this very often, it's very likely that your transaction log would have to grow again, and then you are coming back to the other issues with the log-out to grow, when you are waiting for your place to be 0 initialized and log flushes are being paused. So this could be a problem. Multiple log files. Actually, SQL Server is not benefiting anyhow if you have more than 1 log file, because SQL Server is not using them in parallel, SQL Server is using them in series. So once the first file is full, then you are moving to the second, then to the third, etc. So multiple log files sometimes is required, because if there is no space on your original transaction log file, you might need to add a new file on another drive. But what is the issue here? When this happens, you have to plan on removing this file as soon as possible. For example, if you needed to add a new drive in order to accommodate some kind of a workload, when this workload is over, you just need to plan on removing this file as soon as possible. Because if something happened with your database and you need to rebuild it from scratch, the first step to do it when you are restoring backup is for SQL Server to create the files. If you have more than one transaction log file, for example 2, even 3, my worst situation was with 4 transaction log files. Each of them was around 1 terabyte or something like this. So this reduced the recovery time with several hours of time, because SQL Server needed to zero initialize, instead of only 1 terabyte of space for the transaction log, needed to zero initialize 4 terabytes. So you can imagine the managers are on the other part of the line and just yelling what is going on, and you basically just cannot do anything in order to speed up the process. So be careful with multiple log files. Okay, revert from snapshot, another probably buggy behavior. Have you used this feature actually, revert from snapshot? Have you tried to revert a database from a snapshot? Okay, it's fairly easy and fast solution. First, do you know what is snapshot actually? Yeah? Can somebody explain it? Help? Yeah? No? Okay. Snapshot is a point-in-time read-only copy of the database, and you can use it to revert from it in some case of disaster. But when you do it, SQL Server is recreating your database again with a very small walk, with a walk of 500K, 2 VOFs, 250 each. So if your database has been running with a walk of 10 gigabytes, you would now receive a database with a walk of 500K. So you have to be careful. And last but not least is the physical location of the transaction log. Do not underestimate this. I know now probably with the virtual technologies this is a bit controversial, how performance gain you would get if you separate the data files and the log files, because even if you see logically 2 different drives in your operating system, you don't know what is going on beneath it. But you can still benefit of this, because there are different types of workloads. You have sequential writes against your transaction log and random reads and writes against your database, and also you can use different level of write arrays for the transaction log and for the data files. But please, I know that is tempting, do not put your transaction log on write zeros. I know that write zero is probably fast, but transaction log is very crucial for your database, so please do not do it. These were the configuration things you can do, and I promise you that if you do some of them or all of them, you will be able to enjoy the little things in life and do this. Probably I should have put a beer or something. So enjoy little things, sitting on the beach, watching the sea and drinking, how you call it, pivo. Yeah, drinking pivo. Okay, key takeaways. 1 more minute and I am over. So I wanted to take 3 things from this session. Transaction log is very crucial for SQL Server, for your database. Do not underestimate it, and always customize it and configure it as per your environment. For some situations, there are no magical numbers, but you can at least try to make educated guess about the size and where you can put your transaction log. I included some useful links that if you want more information you can check out. And yeah, unfortunately we do not have time for questions right now. Sorry about this, but I will be here till the end of the day, so you can find me in the hallway, or if you join the party after the event, I will be more than glad to answer your questions. So really thank you for coming. Don't forget to rate this session and all other sessions. And it was a pleasure for me to be here. Thank you again for coming on Saturday, and see you around. Thank you.